Welcome to Chemistry and Science Spectrum. Today we dive into the fascinating world of atomic structure, a core topic that forms the backbone of chemistry. This lecture is designed to give you a clear understanding of atoms from their fundamental particles to how they bond and form matter. Whether you are preparing for exams or simply curious, this topic is essential for the grasping complex concepts in chemistry. We will walk through a multiple choice questions explaining each one in a straightforward way. So, you shall gain the confidence to tackle any question on the atomic structure. Let us get started on this journey into the heart of the matter. First, we explain some important multiple choice questions from the atomic structure. Let's go over the first question. The question is the nature of the positive rays depend upon. Here the four options are the nature of the electrode, the nature of the discharge tube, the nature of the residual gas, or all of the above given options. Positive rays are produced due to the ionization of the gases present in the discharge tube, because an ionization of particular atoms in the discharge tube, they ionize to positive charges. So positive charges are produced, which are the positive rays, and so it depends upon the nature of the residual gas. So what would be the answer to this question? The answer should be the C option, the nature of the residual gas. Next, the question 2 is the velocity of the photon is here the four given options are independent of the wavelength, depends on its wavelength, equal to square of its amplitude, and depends on its amplitude. So what would be the right answer to this question? As we know that light travels in the form of photons, since velocity of light is a constant quantity, therefore velocity of photon is also a constant. So it do not depend upon any of the factors, and the answer to this question is independent of its wavelength. Let's go to the third question. The question is the wave number of the light emitted by a certain source is 2 exponential 6 per meter. The wavelength of this light would be. Here the 4 options are given. A option is 500 nanometer, B option is 500 meter, C is 200 nanometer, and option D is 5 exponential 7 meter. So what would be the answer to this question? For this we have to go to the solution of the answer. Here the given quantity is mu bar, which is the wave number, and it's equal to 2 times exponential 6 per meter. But from this we have to calculate the value of lambda, and for this we use the formula of lambda is equal to 1 over mu. So this formula is the used for the calculation of the wavelength. So put the value, that's 2 exponential 6 per meter in this formula, and we will get this. So we have to put the value mu bar into the denominator. So the answer comes out to be 0.5 exponential 6 minus 6 meter, which can be written as 500 exponential minus 9, and which is equal to 500 nanometer. So 500 nanometer is the answer to this question, and the option for 500 nanometer is option A. That's the answer. 500 nanometer, option A is correct. Now go to the MCQ number 4. The other 4 model of atom failed because here the 4 options are given. The atom did not have its nucleus and electron. Second, it did not account for stability of the atom. It did not account for the attraction between the protons and neutrons. There is actually no space between the nucleus and electrons. We have to think about the options, because of 4 options, one should be the most probable option, and we have to choose the most appropriate option for this answer. First we look at the first option. The atom did not have a nucleus and electron, which is most irrelevant option, because every atom has a nucleus and electron. The second, it did not account for the stability of atom. So we can say that this may be the right answer to this question. And number 3, it did not account for the attraction between the protons and neutrons. It's also irrelevant because there is attraction between proton and neutron according to the modern theories of the physics. And the option D is there is actually no space between the nucleus and electrons. So the option B did not account for the stability of the atom is the most relevant because Rutherford atomic model, the electron must emit energy continuously. As a result, electron will move in a spiral path and will fall into the nucleus, but it did not actually happen. Therefore, the whole atom would not collapse as according to the theory. Hence, Rutherford model does not account for the stability of the atom. So, the right answer to this question is that option B. It's not account for the stability of the atom. Now we have the fifth question, and which is question is Bohr's atomic model is contradicted by the four options of Planck's quantum theory, dual nature of light, Heisenberg's uncertainty principle, or all of the above. We know that according to Bohr's model, the exact position and momentum of electron is fixed. However, according to the Heisenberg's uncertainty principle, both position and momentum of electron cannot be determined simultaneously. Hence, these two are opposite, are contrary to each other. So, the right option will be the Heisenberg's uncertainty principle, which is the most appropriate choice for this question. And number 6, the question is splitting of spectral lines when atoms are subjected to a strong electric field is called. The four options are: number 1 option is Zeeman effect, 2 is Stark effect, and 3 is photoelectric effect, and 4 is Compton effect. So, what is the answer to this question? I suggest Stark effect is the answer to this question, and the reason is that Stark effect is termed as when emission spectrum of excited atoms is taken in an electric field, lines are split up into component lines, and this is the Stark effect. So the answer B is correct. That is, the answer is Stark effect. Now we go over the multiple choice question number 7, and the question is: in the ground state of atom, the electron is present. Number A option in nucleus, B in the second shell, C nearest to the nucleus, and D option is farthest from the nucleus. So what will be the right choice for this reaction for this question? I suggest nearest to the nucleus, because electrons lie nearest to the nucleus and then from apart from the nucleus, that is throughout the outer core of the atom. So the option C is the correct answer. Now, question 8. Quantum number values for 2p orbitals are. Here the four options are given, in which principal quantum number values are given and azimuthal quantum numbers value are given. We should have to think over the question, that is what should be the right choice for 2p orbital. That is 2p orbital, it stands for the n and l values. As we know that 2 stands for a principal quantum number value, n is equal to 2, and p for azimuthal quantum number, and for p value, l value, the azimuthal quantum number values can be calculated by subtracting n minus 1. So we have to subtract 1 from 2 value, and the value comes out to be 1. So the L value for this option is 0 and 1. 0 stands for s orbital, and 1 value for p orbital. So the right option is the first option, that is n is equal to 1 and L is equal to 1. So this is the right choice for the question answer. Here The ninth question is orbital having the same energy are called. The four options are d orbital, valence orbital, degenerate orbitals, or hybrid orbital. What would be the answer? I suggest the C option, because the orbital having same energy are called degenerate orbitals. So the C option is true for this question. Now we go over the question number 10, and the question is, when d6d orbital is complete, the entering electron goes into, the four options is 7f, 7s, 7p, 7d. So for the right choice, we have to discuss the n plus l rule, and the rule is orbitals are filled energy wise. Thus orbitals are filled in the following order. First, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, and 7p. So hence, when 6d orbital is complete, the entering electron will go into 7p orbital. So the answer C is the right choice for the answer for the question. Now, question 11 is number of the electron present in potassium is. Here the potassium atomic number is 19 and the mass number is 39, and the options are given here. A option 39, B option 18, C option 20, and D option 19. So what is the number of neutron in potassium nucleus? We know that number of neutron can be obtained by subtracting proton number from the atomic mass. Atomic mass is 39, so it is subtracted 19 is we have to subtract 19 from 39, and the answer comes to be 20. So the answer is 20, which is the number of neutrons in potassium orbital. Now we are on the question 12, and the properties of the waves, or here four properties are three properties are given, and we know wavelength, wave number, frequency. All of these properties are the properties of the wavelength. This is so simple question. Now we go over to the question number 13, and which is about the spectrum of hydrogen, and the Balmer series is found in. Here the regions, three regions are given: IR region, UV region, or visible region. We know that Balmer series lie in the visible region, so the option C is the correct answer. Now the last question is 14, which is what is X value? For the here the given equation is in which a copper atom is struck by a neutron, and copper 2966 is produced, and some rays are also generated during this process. And what is the rays? So the value of X, what would be the value of X? So electron, proton, beta rays, or gamma rays. The exact value for this answer is gamma rays, because one neutron is absorbed into the copper nucleus, and 65 goes to 66, and only gamma rays are produced in this question. Hope you have understood the question answer idea thoroughly. See you again in the next lecture with a fascinating video. Express your views in comment box, and do not forget to subscribe the channel if you are new to the channel.